I am Shannon Miller, and I am the undergraduate advisor for Civil and Environmental Engineering. And first off, we have Dr. Omar Ozbek. She is going to, she's an environmental engineer instructor. And so she's going to start us off with our first 20-minute mock lecture session. So Dr. Oz, I'll let you take it.
Perfect. And in my class too, especially when it's face-to-face, it's a little harder online. I'd like this to be a conversation. So please feel free to unmute yourself and give me answers, and I will wait for a little bit until I get an answer for the most part. When I'm sharing my screen, which I will do, it is harder for me to see the chat. So if Shannon, if there's a chat input, I would really appreciate if you can let me know of those inputs as well, because I'd like to give the opportunity, especially on an online setting, to be able to contribute through chat rather than unmuting yourself if it feels more comfortable. So let me start sharing my screen. Where's my Zoom? Okay, I should be able to do this. Share. Do you see the slide? Perfect.
Yes, it looks great.
All right, let me move the videos. All right, so this is one of the fun topics we cover in civil and environmental engineering concepts class. I also teach this course to civil engineers as well. So even if you're not, if you're sure about your major, if you want to be a civil engineer or an environmental engineer, when you take this course with me, you will be exposed to this material. And the good thing is environmental engineers really enjoy talking about these topics. We try to go a little deeper with that course, the concepts of environmental engineering, also with the upcoming courses. With civil engineers, it's also an eye-opening experience that it helps them recognize our impacts on the environment as humans through our activities and what we can do. So I hope you will enjoy this short session as well. So this module typically covers water quality, the pollution, the pollutants, and how we can manage those. So a few specific topics we go through are water pollutants and their sources, and then we take that information into water pollution in rivers, because it is very critical when we discharge pollutants into the rivers. The aquatic habitat relies on dissolved oxygen concentrations, and we have a sag in the DO, the dissolved oxygen, when a waste is discharged. And then we take it to the lake system level and recognize what might go wrong within a lake system, a surface water body, when we have higher levels of pollutants discharged to it. Today we have a very limited time, so we're going to be talking about the water pollutants and their sources, and I'm hoping to have a hands-on activity all together again. I think that's when we will have some fun, hopefully when we get there, as we go through that example. We do have two main learning objectives out of this module, even within this 20 minutes mock lecture. The first one is to be able to list and explain the adverse effects of pollutants on surface water quality. And then we would like to recognize where those pollutants come from. They come from either point sources or non-point sources. I would like you to be able to define those as well after we're done with this segment. Before we go into the material though, I would like you to watch a video. I checked it triple times, it worked, so hopefully it'll work. Can you see the video?
Yes.
Thank you, Shannon. So kayakers are having fun, but something is wrong. Is this how the river supposed to look like? What is wrong?
Yikes, I don't think it's supposed to look like that. It's a little muddy.
It is a little muddy. Why would the river be muddy like that? Any ideas?
Is this related to wildfire?
Thank you, Rachel. It is unfortunately related to wildfire, not the most recent one in Colorado, which was devastating, which was much bigger than what you saw here. This was 2012 High Park wildfire, and the water really ran black. After the wildfire was put out, a few weeks later, we had a rainstorm event which carried all the ash into the river, and the water looked as such. Again, at that point, it was the second largest fire in Colorado history. It was a huge area that was burned with different burn severities. The firefighters did their best to control it. Unfortunately, one woman was killed and several homes were burnt. And it was a challenge for the water treatment plant and also for the ecosystem as well. We're going to come back to this, so please hold on to this information, and unfortunately sad case for the example as we will discuss further. The pollutants that come into our surface waters might come from two different sources, as I have briefly mentioned with our learning objectives. They might be coming from point sources, or they might be coming from non-point sources. And to get some inspiration, I have two photos for you there to signal what might be considered as a point source and what might be considered as a non-point source. Anybody has an idea what could be a point source or how you would describe it?
Maybe like snowfall?
For point sources?
Yeah. No?
What do the class think? Does anybody have an idea about that? What would be a snowfall? After the snowfall, it melts? Would it act like a point source, or it would act like a non-point source?
A non-point source.
A non-point source. Thank you, Ridley, sorry. Why do you think it's a non-point source, the snowfall event?
Well, I think that a point source might be something that can be pinpointed to a specific location, like the picture is like a pipe, so like could be pinpointed, whereas snow would be widely distributed.
Very good. Shannon, was that clear for you that the point source typically could be identified pinpointed from a point source, but snowfall is over a large area?
Yes, that makes so much more sense.
Perfect. So as Ridley said, point sources, you can really identify that point that the waste is being discharged into the environment. Typically, we observe it with wastewater treatment plants or industrial wastewater treatment plants that treat our wastewater and discharge it back into the environment. The good thing with the point sources is that because we can really identify it, where it comes from, where it ends up at, we can go back to the polluter and say that this treatment is not working, do a better job, so that we can really control its impacts on the environment. As Ridley mentioned, the snowfall event, it is over a larger area. It comes through, especially when it melts, it comes through different points over a larger area. So it is the runoff over that, over the land. It is really hard to control it. It is really hard to track it. Snowfall, we probably would not have a much concern over. However, if it ends up in an agricultural land and carries all the fertilizers, the pesticides, on the livestock operation, the manure, it will create a lot of issues. And because it comes from so many points, it is harder to track back who is the offender. What we can do is assess the area. And if we see agricultural applications or livestock applications, we can ask them to apply best management practices. And the best management practices would be to ask them to utilize lesser amounts of fertilizers, lesser amounts of pesticides, because more fertilizer doesn't translate into better crops always. So we can try to control it as such. Of course, for urban areas with whatever might be on the roads, maybe the oil leaking from the vehicles, or I really appreciated during winter when we apply the salt so that there's no ice on the roads or the sidewalks. but then it ends up in the surface waters. It is a little concerning, so we might have to deal with that as well after a rainstorm event on urban areas. So those are the basics for the point sources and non-point sources. This is the overall table that summarizes the major pollutant categories. We have 8 of them, and we're going to briefly discuss them. This will be supported by the reading assigned from the book so that you can get more out of it as well. Of course, if it was a real class, but for here, we're going to briefly touch base on them. As you see those several different pollutant categories, this table also really well summarizes it really well if they come from a point source or if they come from a non-point source, or it could be coming from either of those, and further categorize it if those pollutants are found in domestic wastewater or industrial wastewater, and if it's coming from a non-point source, is it coming from an agricultural runoff or an urban runoff? And as you can see, some of the pollutants can be present in any of those sources. Some of the pollutants can only be found in just 1 or 2, like personal care products, the shampoos, the conditioners, the sunscreen can only be found in domestic wastewater and nothing much else. So let's zoom in on those pollutant categories quickly. Again, this will give you an idea about what those pollutant categories are and what their impacts could be. And then this will carry us forward to our example, hopefully, where we will have fun. Oxygen demanding materials. Oxygen demanding pollutants are one of the most concerning pollutants that we are challenged with in the surface waters in the environment. As the name implies, those are the materials that will demand oxygen, that will consume oxygen. And because, like us, the aquatic habitat depend on the DO, dissolved oxygen, if we discharge a lot of oxygen demanding material, we will lower the dissolved oxygen levels and affect the fish. And that is a real picture. The fish died and ended up on the beach because there was not enough dissolved oxygen in the water for them. The oxygen demanding material could be coming from natural sources, the plants, the trees dropping their leaves and it's decaying. But typically the concerning issues with the oxygen demanding material is us, human and food waste that we discharge into the environment. Another very concerning pollutant is the nutrients. Nutrients, when you hear about it, sounds good. Nutrients, it should be beneficial. And yes, nutrients are beneficial and necessary for us and for the aquatic habitat, for the environment. However, if you were to take a lot of vitamins, as it would hurt your body, if we discharge a lot of nutrients into the environment, it will impact the balance and impact the water quality as well. Nitrogen and phosphorus are the top 2 concerning nutrients we are challenged with discharge into the environment. And they will exacerbate algal growth. And you see from that beautiful green lake photo, but it's not supposed to be looking like that. We have a massive algal bloom. It brings in its concerns. When algae is blooming, it creates already issues with anesthetic conditions. They release taste and odor compounds. Some algae, hazardous algae, release toxins. And when they die and decompose, they act like oxygen demanding material. So it's a lose-lose situation. And the nutrients mainly come from the detergents we use, fertilizers applied onto the agricultural land, and any other food waste. We also are concerned with pathogens. What do you think pathogens are? This could be a relatively easy question. Pathogens. Do we like them?
No.
No, we don't like them. What do they do?
Infect things.
Infect things. They make us sick. Thank you so much, Shannon. So pathogens could be bacteria, viruses, protozoa. It makes water non-potable, not okay to drink, and in some cases not okay to be in, like you cannot go fishing, you cannot go swimming. We have different kinds of pathogens we are worried about around the world. In US, Giardia and Cryptosporidium are the top two that the water treatment plants target. Around the world, cholera, typhoid are the other kinds of pathogens that are worrisome. So we have to inactivate them to ensure that the water is safe to consume and safe to swim in.
I have a question about the Giardia. My dog got that after she was drinking out of a river in Fort Collins. Is that common? Like, should we not allow our pets to play in or drink in the water?
Typically, it shouldn't be as bad to make your dog sick, but maybe there was a case of maybe there was fecal matter nearby, so that the levels were higher. We see these pathogens everywhere. The level is also important. The amount you ingest and consume is important. So if you were nearby a wastewater treatment plant that doesn't disinfect their water, or maybe a fecal matter from an animal, it could be the reason why.
Okay, thank you.
You're welcome. And just a quick note especially for summer months, it fluctuates in Colorado. If you see any algal bloom, don't let your pets drink from that water either with the toxins, because there have been really sad situations where the animals ingested the algal toxins and got sick or passed away. So that's something else to keep in mind. Suspended solids are another type of pollutants. They could be organic or inorganic in nature. They are typically bigger in size, so they will settle out. And maybe after wildfire, they might be at higher levels, but if we allow it to sit in the river or sit in the lake, they will hopefully settle out. But if they are smaller in size, we call them colloids, and they cause turbidity. And as we would not want to inhale air with particles in it, fish would be bothered or affected from the turbid water as well. So we have to manage the input of suspended solids into the surface water bodies as well. Another concerning type of pollutant is salts. We measure it as total dissolved solids. If you are an environmental engineer, we do have a laboratory class that you would experience it firsthand, hands-on. We filter the water, we evaporate and check the dissolved solids. Too much salt is not good for anyone, humans, animals, crops. So we would like to ensure that the levels discharged into the water bodies are at an acceptable level. Typically, the main contributors of salt are industrial wastewaters or the de-icing agents on the roads. But it could be also natural. Colorado has more saline soils, so it could also impact the salinity of the surface water bodies as well. We have toxic materials category, and they could be organic in nature or they could be metals. Typically, these kinds of toxic materials are found in pesticides and herbicides we apply onto our agricultural fields. Industrial wastewater might also contain these toxic materials. The concern with these potentially heavy metals as well, that they are stored in the fatty tissue and they bioaccumulate. They are stored, we cannot eliminate it. And as you see in that diagram, small fish eating, the bigger fish eating smaller fish and going up in size, if we have an issue in the water body, the fish will accumulate it in their fatty tissues. And as you go up the food chain, you will find much higher levels of these toxic materials as well. They persist and bioaccumulate. And I have last two kinds of pollutant categories before we move on to our example. Endocrine disrupting chemicals. They are the materials that might mimic hormones so that your body thinks that you have that hormone and it will alter the function your body works or alter the way the aquatic habitats function, hormone system works as well. I do have a crab there, and it is one single crab. And what do you see with that crab? What is interesting about it? What do you observe with that crab in the photo? Do you all see it?
Yes, I can see it.
Shannon, what do you observe? Or Rachel, I think she unmuted herself. What do you see with that crab? There's something different about it.
Clouds are two different colors. I don't know if that's what you're referring to.
That is totally what I'm referring to. The claws are not supposed to be different colors. One claw is red, the other one is blue, which means that it's half male, half female. It is not how it's supposed to be. This crab was caught in Chesapeake Bay. It is a highly polluted area water body, so it could be that this crab was exposed to endocrine disrupting chemicals that caused it to have such a feature. Again, we observe fish populations changing gender from 50-50 male-female to 80-90% female because of the discharge of these endocrine disrupting chemicals. And heat, it sounds interesting, heat as a pollutant. Yes, it could be considered a pollutant because some fish prefer to live in cold water, so it will render the waters inhabitable for them. The heat will also impact the dissolved oxygen concentrations, which means that if we have any discharge of oxygen demanding material, the conditions will get worse. So we need to be mindful of the temperature of the water that ends up in our surface waters as well. So this is the brief overview of the pollutant categories. Again, this is well supported with the reading assigned from our book. All right, let's recall the very first video clip we watched, and you identified it really well that it was the Poudre River right after or soon after the High Park wildfire, and the water after that storm event ran black for days. So what I want to do is, I hope you will feel comfortable doing that. You can annotate on your screens, and I think the best way, if you have a tablet, it's easy, you can write on it. But if not, you can type as well. Take a look at all these pollutants and put an X on the types of pollutants that you think was present in Poudre River as we watch that clip. So I'll give you about a minute. Perfect, I already started seeing the X's. And also, as you do it, think if the pollutants discharged into the river were coming from a point source or a non-point source. You can put more than one X if you think more than one pollutant was in the Poudre River. All right, I'll give you 15 more seconds. Rachel, you have a question?
It just took me a minute to figure out the annotation, but if you look at view options on the top and select that drop down, there's stamps and things so you can draw. That's very cool.
Thank you, Rachel.
Thanks for teaching me this, something new.
This is one of my favorites. But it looks, I realize it looks different than on my screen than the student's screen. Well, after you explained it, now I see more input. Thank you, Rachel.
No problem.
All right, last 10 seconds if you want to get in more. All right, I hope you had some fun. I like to do this actually, if we have more time, get in breakout rooms, discuss it, and then come back and put our answers on. What I would like you to do at this point is just quickly recap this example. My first question is, were the pollutants coming from a point source or a non-point source into our Poudre River after the rainfall event over the watershed?
Non-point source.
Thank you, Ridley. Non-point source. It had multiple points. Actually, I had a research project on it. We could find ash over a 16-mile stretch in Poudre River that brought in ash and all the other the sediments. All right, let's take a look at the inputs. Oxygen demanding material. I have mixed feelings about this because it was somewhat of a severe burn, but it mobilized the plant material. And as you might argue that maybe some of them were not burned as much, and they would still act as an oxygen demanding material, and they ended up in our river. And I would agree with that too. I have quite a few inputs on the nutrients, again, probably coming from the burnt material. If it is a severe burn, if it turned into black ash, probably not so much. But I'll tell you more about the nutrients and why I will agree with this input as well, that during our firefighting, the helicopters would drop fire retardants over the fire, but it was hard, and sometimes they would miss, and they would put fire retardants in the areas of not burning or even directly onto the river itself. And fire retardants contain nitrogen species. So yes, there could be some input of nutrients either through not fully burned plant material, but also because of the fire retardants as well. Pathogens is an iffy question. Maybe I should phrase it a little bit better as I ask this. We always have pathogen input into the river because of the wildlife, but probably was not highly exacerbated because of the fire. But of course, we always have pathogens in there. I was hoping to get a lot more X's on the suspended solids. You saw that black water. We had a lot of ash. We had a lot of suspended solids come in. So this was probably the highest amount of pollutants that we saw in Poudre River after the wildfire and after the storm event. Salts could be coming from the fire retardants, toxic organic chemicals. Again, we don't have much time, so I wish we could just discuss this, why you said we would have toxic organic chemicals. Typically, students think that the houses were burned, so they could be coming from there as well. And heat. Even though we put out the fire, there could be still some hot spots eventually. They could bring in some heat as well, so that is a great input as well. So this concludes I'll stop sharing my screen. This concludes my section. Again, I wish we had more time, but I hope you got something out of it, and I will stay for another minute or so. I know Dan needs to go after me, so I'll stay for another minute if you have specific questions for me related to environmental engineering courses, and then I will have to leave.
Dr. Oz, thank you so much for your presentation. That was very informative and certainly very interesting.
Thank you.
Yeah,
I agree. That was really fun for me as a non-engineer. It was very interesting to see what some of our students are doing. So thank you for sharing.
Thank you. Of course, my pleasure.
Okay. All right. We got a thank you. So there you go.
All right. I will leave. Have a great rest of your day.
Okay. Thank you. We'll talk to you later. Okay, next up we have Dr. Dan Baker. He is an instructor in statics, dynamics, several courses of ours. So I will hand it over to Dr. Baker.
All right. And if everybody has it, I'm going to use the whiteboard up here. So hopefully you can all see me. And in the top right, if you're only seeing me as one little square, you might want to switch from gallery view to presenter view, and then you'll see me a little bit larger. But my name is Dr. Dan Baker. I'm still seeing Shannon, but I think that's fine just because, Shannon, you see me big? Just double checking. Okay, great.
You're big on my screen.
Okay, excellent. So I teach statics and dynamics, which are kind of sophomore to junior level courses, depending on when you take them, that you take basically after calculus 1 after physics 1, and then you come into statics where nothing moves, and in dynamics, everything moves. And myself and Dr. Oz, who just presented, as well as our third presenter, Dr. Nicole Ellison, are actually all full-time instructors here in the department. And so we have, there's currently 3 of us, and we're hiring a 4th. And so you'll see some full-time instructors. We all have PhDs and doctors in civil engineering or environmental engineering. And then you also see some tenure track faculty who basically do a split of research as well as teaching. So just kind of give you a little context of who you're seeing today. So I've taught here in the department for 5 years. I love teaching, and I look forward to today to talk to you about slipping versus tipping in the topic of friction. So this comes from Civil Engineering 260 Statics. And I have set up a little kind of pre-survey to get your brains going and thinking about what you already know about friction. And so this is in Mentimeter. I pasted the link in the chat, so you should be able to click on that link and it'll take you directly to the questions. Once you land where you're supposed to be, you should see "Welcome to Engineering Exploration Week at Colorado State University." Okay, so if you're there, either on your phone or on another browser tab or whatever you're using for that. Okay, so the first question is, when you hear the word friction, what words come to your mind? A few of those coming in. Let's see, how many people do we have total? There should be, just looking at my numbers, I see 3 people are in the survey, and maybe some of the others are not signing in, which is totally fine. I see words here showing up: force, stuck, and heat, which are great words thinking about friction. But fundamentally, friction is going to be an interface between 2 surfaces. If you rub your hands together like this, you'll feel that friction. Not only is a drag between your hands, but actually we're building up heat because of that friction. Essentially, friction is kind of a loss when it comes to energy because we're burning some of that movement into heat. So my second question, this is going to be a little more technical, okay, is select all of these statements which you believe are true. Okay, so it says select all. So, and I'll tell you there's more than one of these that are true. And I'll also give you a hint, it's not all 4. Okay, so it's somewhere between 1 and all 4. All right, we got a few responses in. Here comes a few more. Awesome. I'm guessing that's probably about everybody. So I'll go ahead, and it should show on your screen that the correct answers are: friction opposes motion. Friction is a function of the normal force, normal meaning perpendicular force. And also friction can be available but not engaged. And we're going to talk about a bit about that one today. So the only one that's false is that friction is always at impending motion. A lot of students coming into statics have just come out of physics, and they see the word friction and they think, oh, this is all impending motion, but it turns out it's not. It's actually some ranges of friction. We'll talk about that today as well. So that gives me a good feel for where you all are. All right, so if we have a block, and this block is sitting here on a horizontal surface. So we have that on the board, and then I also brought in a little model. There we go, block on a surface, okay? So what we're gonna do is we're gonna create what calls a free body diagram. In a free body diagram, we're gonna take this block, we're gonna remove it from the surface, and we're gonna draw all the forces that are acting upon this block, okay? So I'm actually gonna remove my surface here for my free body diagram, and I have a normal force. Now, often we draw this normal force with one single vertical force. It actually turns out, if you think about the force coming from the surface up onto that block, it doesn't act in one point. It actually acts up across the entire surface, right? All the way across the bottom here. So I can just show down here that really that normal force is coming from a distributed force. And it turns out to be not even just a two-dimensional distributed force, but actually is a three-dimensional distributed force going into the board. So this is either our normal force or this is our normal force. Okay, just realizing that they're equivalent to one another, but this is basically an abstraction of this. And there's gonna be a weight force, right? We're here on Earth, and so we have gravitational acceleration acting upon masses, which gives us a weight. Now, another question that I can ask related to this is I haven't drawn a friction force onto here, but is there friction available between this block and this surface? Hopefully your head's kind of maybe slowly nodding up and down. There is friction available here. We're not using any of it yet, okay? So on a free body diagram, you don't necessarily need to draw forces that are not engaged. We could if we wanted to. We could say, hey, let's draw the force going this direction. So here's my friction. I'm just going to put a note there that it's currently equal to 0. Okay, it has a 0 value at this moment. All right, and so this would be a situation where we're not using any of the friction. We have this non-engaged friction. It's available between this block and the surface. We talked about a distributed load. We talked about converting that into a point load. Okay, so that's the simplest situation. We're not using any friction. Let's create another situation. And that is going to look like this on the board. We're tilting now, let's put dotted lines for my surface, tilting this surface, right? So here's my block. I start to tilt the surface. The block doesn't slide yet, right? But as we go a little further, a little further, a little further, oh, there it slid. Okay, what we did there is we actually reached impending motion, which is when it started to move. And it actually went from engaged friction, but not impending to kinetic friction. Let me draw a graph of that over here in this corner. So I'm going to put here on the vertical axis, this is our friction. I'm going to put it here on a horizontal axis. You can think of it either as an angle, which we're looking at fundamentally, friction as a function of angle. It can also be as a function of like a pushing force, right? If I was pushing sideways on that block. And so what this friction curve looks like is we start here 0 friction with basically either 0 angle or 0 pushing force. And then we have this linear increase in the friction until we reach this maximum friction point here. We dip down and it goes horizontal. Okay, and so hopefully those of you who've taken any kind of physics course remember and can look at this and go, I think this point right here, this is that impending motion point. Realizing I'm probably running way too small for my camera and this distance here, but at impending motion, we can say that our friction force is equal to our friction coefficient, mu sub s, times n. Okay, that turns out that's our maximum friction. So looking over here at this one, if we call this scenario 1, that's right down here. Okay, scenario 2, if we're reaching a point of slipping, let's go ahead and add some things here to the free body diagram. Here is my normal force. Now, one thing to keep in mind is that friction opposes motion. And all of you, all but one, I guess I'll say, got that correct on our earlier survey. So opposing motion means that the block wants to go this way. And so the friction is going to oppose it, going in the opposite direction. Now, the weight force will still be vertical. That's close enough to the center. Okay, so noting in this problem that our normal force, which is perpendicular to the surface, and the weight force, which is vertical, are not parallel. Okay, that's another misconception. Students often come out of physics thinking, hey, all normal forces are equal to weight forces. Not always true, depending on the situation. So this friction force, if this is at impending motion, so I'll call this number 2. And this is impending motion for slipping. If you think about the words impending motion, it really just means it's about, something's about to move. Okay, it can be about to slip, or it can also be about to tip. And so this is going to be this point right up here. And then I'm going to draw another scenario. Keeping in mind, we are in statics. There'd be a fourth scenario over here with kinetic, where that block was actually moving, but that's not the class we're focused on today. So in thinking about statics, the last scenario would be tipping. And so what happens in tipping is that this normal force here, fundamentally, you'll notice that here the normal force was in the middle. Here the normal force is no longer in the middle. It's actually traveling down toward this corner as we push harder and harder. Eventually the normal force gets to the corner. Oh, better draw that perpendicular to the surface, not vertical. There is my normal force. My friction force is shearing here along the surface. There's my friction. My weight force still acts down through the center. So what this looks like with our physical model, and I'm going to cheat here a little bit. I had to do something to change up the scenario so I could get it to tip versus slip. I added some of this like sticky rug stuff to my surface. Okay. So now I tilt my surface, tilt, whoa, still going, tilting, 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 tilting. Oh, there it goes. It tipped. Right, so I had so much friction available here. By adding that sticky surface, I actually changed my friction coefficient, that I got it to a point of tipping. So one of the key things I want to talk about here is at this case of tipping, do you think that tipping happens somewhere in this linear section of the graph? Does it happen up here at impending motion? Or does it happen maybe over here in kinetic? I didn't set up a survey question for that, so you can answer it in your head. You can type it in the chat, whichever you feel inclined to do. So again, I got three options for you. It's going to be over here in this linear section, here at impending motion, and over here would be kinetic. Those three different phases of friction. Where would tipping happen? Okay, I had a guess of kinetic. Any other guesses before I reveal the big reveal? All right, hopefully you're like saying this in your head. You're like, I don't want to guess right now. It actually happens over here. It turns out that the amount of friction that we have available is not yet enough to slip. And you can think about that as you look at this block right here, right? So the motion that happened with this block is it decided to tip before it slipped. If I did this same motion again without that sticky rug mat, and I tilt, here it quite easily slipped first. Okay, so fundamentally the controlling angle for slipping with given this surface would be this angle, quite shallow, versus the tipping angle putting that rug mat on here was quite a bit steeper. Okay, and so in either case, it was at the threshold of motion, at the threshold of tipping, or the threshold of slipping. But one of the key things, like I said here, is to note that this number 3 actually happens somewhere in here. We don't know exactly where it happens. And it just depends on how sticky that surface is, essentially, and how close we were to slipping at the point where it tipped. Now, you could design a scenario where it's going to slip and tip at the exact same point. And like I said, you can numerically kind of get those to converge. But in most cases, the system is going to choose to either tip first or slip first, depending on the conditions. Okay, so again, this is a lecture from statics. In my teaching, I think of it as mini lectures and then active learning. And so kind of a yin and a yang, where you have some time of me talking to you and some time of you talking to your fellow students, working on your own, answering questions. Some of that happens before you learn, like we did today with the survey. Some of it happens after you do some learning. You can check your misconceptions. Maybe I give you another problem and have you plot where those things lie on this friction diagram. So that's just a little snapshot into statics in this topic, and you'd see something like this very similar. Hopefully, when you come here to CSU, and I can get to meet you and get to know you and teach you in Civil Engineering 260 statics. So happy to take any questions that you might have.
So I'm thinking about like applications of this, and I'm thinking about like a vehicle on a slanted roadway. Would this be one of the situations where civil engineers might use this application?
Yeah, absolutely. There's some direct applications between friction and transportation design in a couple of different contexts. One of those, and the simplest one, is you could think that say you're building a parking garage, right? And you want to make sure that cars aren't going to spin out just driving up in that parking garage. So the pitch that you put the ramps would need to be limited fundamentally by whatever you think the worst surface condition that ramp might see. Maybe rain, maybe ice, maybe whatever else. But another one that's a little bit more complex, but almost every single roadway, it turns out as you go through a curve, right, you're going through a straight stretch and it's pretty flat. It's never totally flat because you want the water to run off of it. But as you get into a curve and say the curve's going to go this direction, that roadway starts to tilt. And as it tilts, what you're actually doing there is you're getting an interaction between the amount of force that the road needs to push your car toward the curve to hold it into the curve. This is getting a bit of the dynamics, but you still got that normal force perpendicular here. And it turns out there's two different frictions. There's one friction that if you wanted to speed up or slow down your car, but another friction that comes on the side of your tires. And so essentially you can think of this as the front of your car, this being the normal force, this being a friction force holding your car up that slant. And so that'd be another basically design consideration where we can only have we want a certain amount of super elevation to make it more comfortable coming through this curve, but you actually don't want to make it too slow, because then if you had a car coming through that was going very slow, it actually could slide down that curve if the surface conditions were slick. So yeah, a couple different.
A semi and some, and then add the wind force, you could actually get a tip, maybe.
Yeah, and that as well, exactly. And so in statics, we end up ignoring all the fluid interactivities of drag force and wind force and whatever else. But certainly, if you've ever driven through Wyoming, you realize that wind tips over semi-trailers and fifth wheel trucks or fifth wheel trailers and everything else. So yeah, there's all these different interactions. And so often as an engineer, we want to design for the worst case scenario, right? So we're like, all right, if there was wind and the road was icy and these different things, what would be the optimal speed, which is also exactly why you see variable speed limits on some sections of road, because they've actually pre-computed what's going on and say, hey, given this surface condition, and so that's related to stopping distance as well, which is another friction related item. But what's the safest speed? Essentially, these assumptions we made in design may not hold true anymore if it's icy and cold and wet and whatever else is happening. Other questions, comments? High fives.
You deserve 5 of them.
Thank you. So I'm going to stick around if I know that the next one coming up is a video, but I'm going to stick around for any questions toward the end, if we still have some time at the end. So I'll turn things back over to Shannon.
Great. Thank you so much. I am going to now start a video for you all. The video is from one of our other instructors. She also teaches statics. She does the Civ 305, which is the intermediate AutoCAD. I think she's doing steel. She does a lot of instruction in our department. So her name is Nicole Ellison. I guess I should have started with that, sorry. And she's a great instructor. She's been at CSU since last fall. So she's a newer hire, but she does a great job. So I'm gonna start the video here. And hopefully you guys, hold on a second. Okay. Rachel, can you see that?
I can't.
Okay. So here we go.
So this game we're playing, Family Feud, have you all heard of it? Yeah. So I'm going to who didn't? It's like a game on TV where you win money, I think. Anyway, I'm going to split kind of down the middle. You can decide if you're on team 1 or team 2. And you have to shout out the answer, but there has to be a little consensus. But the reason for this game is why you guys made concrete, right? So why is the mix so important? This is the question that I want to kind of cover in the first part of today's lecture. Why is the mix so important? So we're going to get started with the game. Yeah, just show question. Okay. So, and this is Nicole's reasons because I know it's going to be a little subject. So, team one, you're going to start first. Why is it so important? Strength. Okay. We're going to do that as number one, aren't we? It can fail, right? Strength you need, it can fail catastrophically. All right. Team two, why is it important? Why is it important? Okay, number two. Number two. Could save your life, right? You have tornado structures, you have, that's what I was kind of thinking of. All right, team one, why is it important? Durability, yes. Yes, yeah. All right, why is it important? Things need to last, yes. How about do that one? So has anyone heard of Frank Lloyd Wright's falling water structure? Yes, made out of concrete. And it's had a lot of creep. And then they had to reshore it. Anyway, I'll show you a picture. We can talk about that later. All right, where are we here? How it flows, the mix and how it flows. I think it's not in here, but let's just go ahead and keep moving. Let's do it for. It is important because for forming it, so like construction, forming, curing. Okay, why is that important? There are buildings, because it has to meet building standards? Yes, it does. How about that? Cost you money. Cost you money if you get sued, but really it could not perform. I was thinking is if you have concrete that's placed with a poor mix and it doesn't perform, then you're going to have to replace it in a short time. It won't perform. Okay, which side are we on? It's used a lot, yes. That's just 10. Or this one, yeah. All right, one more. I know, it was my interpretation. What else? Yes, it needs to sustain the load. But we're just going to move along and do number 8. That is kind of... so, yeah, okay. Okay, all right, let's keep going. Oh, how do I... Oh, I am. I gotcha. Okay, so I wanted to kind of go through, we have another round, but I'm going to hit that next. I wanted to kind of go through your next few weeks looks like so you can kind of mentally prepare. So we're here where the red arrow is. We're going to spend another week on concrete next week. And then we're going to hop into steel. We're going to spend 2 weeks in steel. And then you have your first exam coming up like October 8th. It's a Thursday, and you need to block that time out. You don't have to take it here, but you need to take it during the class time. So we're going to have like the 50 minutes. You're going to take some of it during the class time, and some of it's going to be take home. So you should anticipate every week having a challenge or a quiz or something like that along with your lab. That's your learning exercises. 30% your lab. The semester project will be unveiled next week. Dun, dun, dun. 30% your exams. So this is from the syllabus. So this week you have your COVID seating chart worth 10 points, which is super easy. For those online, all you have to do is put a B in. I'm just trying to account for every student. And then there's a quiz coming up and you have your lab. I did post this lecture as well. So this is kind of, if you go into assignments, you can kind of see your upcoming assignments. All right, so now we have one more game to play. See if I can get there. I got this off the internet. Yeah, let's see. Oh, here's round 2, yeah. All right, so here's the next one. And we can just shout out if you guys want. So what are the biggest factors that impact concrete performance? Weather. You got number 1. We're on the same page. Oh, here.
That's okay. I got it.
Yeah, it's environmental factors, right? So whenever you're designing anything, you need to know what kind of weather it's going to be exposed to. You need to understand what the environmental factors are. Are we designing a pool? So now is it going to be subject to de-icers or chemicals? Is it, somebody mentioned that they have termites in their home country. Florida has them as well. You know, those environmental factors are really important. So, what else do we got? The materials to make it, yes. It could be any of those.
Yeah.
Can you be more specific? What materials go into concrete? Yep, but be more specific because I have a whole bunch of them. Sand. Okay, let's do aggregates. What else? I gave you a hint, right? Nice. I think you got my number 2. Loading. Right. So is it getting truck loading? Is it getting people loading? Is it getting snow loading? Is it getting machine loading? So that's really important. Is it dynamic or is it static? All right, what else we got? Yeah. Say that again? Yes. So let's do admixtures for that. You go back. Oh, here we go. So admixtures. And then I also heard water cement ratio. I don't know. We're just playing for fun. All right, what else we got? How it's cured? Yes. Construction. What else? How it's finished? Yes. Yeah, I kind of lumped that in with construction. What else? What else goes into the concrete? Sand. What else? Sand. Cement. Yes. What type of cement is used? Okay, so one more. Think about one more thing. Think about the duration of the life of the concrete. Is that important? So I said age because concrete doesn't last forever if you don't take care of it. So if you subject it to water and chemicals and things like that, over time, it's likely to deteriorate. Okay. All right. Okay. So I'm just going to go through these kind of quickly because we've already talked about them. So we talked about the loading. This is you get to listen to the Family Feud the whole time? I think it's on there. All right, we'll just go here. So essentially, when you have a seismic event, you're going to have this lateral loading, and the last thing you ever want to happen with your structure is that it fails. This is falling water. So Lloyd Wright is a famous architect, and he had this envision of this house that had these really long concrete cantilevers. They had these slabs cantilevering out really far. And what happens with concrete and wood is over time it creeps. So it deflects and will deflect more. And so you have to be really careful. I actually had a project in Durango. There's a college there. And they had this slab that was out there deflecting. And they're like, it's so uneven, you can feel it. Let's put some more concrete on it to level it out. It's a cantilever. What happened? It deflected more. So then they said, maybe we should hire an engineer and have them look at it instead of just throwing some more load on it. So we have to take that into account when we do our designs, that it's going to creep. And you don't want to have one of your structures. That's the last call you want. So the other thing is, it is important, we talked about those environmental factors. Is it going to be placed when it's hot or when it's cold? And then after it's in place, is it going to be subject to cold and hot? So the civil engineering building is a concrete structure, and most of it's enclosed, so it's firmly controlled. Whereas if you had a garage that's outside or a street or a walk, it's going to be exposed to those climate changes like we have in Colorado, right, where it's like 90 degrees one day and the next day it's snowing. And that type of concrete, so again, this is an environmental factor, right? You've got seawater, but you can specify a concrete mix that will resist your environmental factors and protect your reinforcing. That's why it's so important. And you need the correct slump. This is a bunch of honeycombing. I did a project, one of my very first concrete projects, and I put all this steel in, and then I didn't really think about the laps in the steel, which basically double the area, and I had honeycombs everywhere. It was a nightmare. And so you have to understand that there's two things, right? You can't put so much reinforcing that you can't get the concrete in, but you have to have a slump that will basically, move and coat your reinforcing. So the other thing that's important about concrete is it's really heavy. And when it hasn't hardened yet, this is a project under construction. When it hasn't hardened, they have to keep shoring in place in order to make sure it doesn't fail. And I'm not going to show you the video, but you guys should go back into the PowerPoint and watch it because it fails. And it happens more than you would want to think that it could happen. They start pouring the concrete and the shoring fails and somebody gets hurt. So concrete's tricky.
Okay, that was the end of Dr. Ellison's presentation. So it looks like, oh, was it not on the whole time?
It was on.
Oh, okay.
Yeah, you're good.
I get what you were saying, Dr. Baker. Dr. Baker, I get it. Okay, so if anyone has any questions, Dr. Baker can probably answer some questions from Dr. Ellison's presentation as well. If anybody's got anything.
I used to test concrete. Like I had a whole summer internship in college where I tested and tested and tested concrete. So I haven't done as much like design, but I know my concrete mixes.
Yeah, it's some of those pictures that she shows, like, that's just incredible to me. I guess that's engineering.
So are there concrete structures just basically all over the world that haven't been created correctly? Is this like a concern?
Yeah, I mean, just speaking super generally, I think that there's, building codes in most places. It just depends on like, how closely that those are monitored or adhered to is probably that's probably the bigger variant than the existence of codes. Like, any country or city or state or anything else, like there's very standard codes for things. And they can say, we conform to the International Building Code. But if it actually gets built that way or not is more of an inspection question.
Interesting. Okay.
Probably one thing she didn't point out, but she talked about the age of concrete and it like lasting a long time. One thing that concrete, people putting concrete down will sometimes do, which is bad, is in the finishing stages, they'll add extra water. And like what you'll see if they've done that within about 5 or 10 years, like the very surface layer starts all cracking off and you can kind of see the rocks that are underneath. And what that's indicating is they probably didn't get the concrete placed quick enough. It was starting to cure. They tried to add a little bit more water to make it more workable. But what they basically did is they weakened that top layer because there's like very exacting ratios of concrete to water. And when you go over those, like your strength just plummets. So even though it was like easier to make it look good, you actually, in a long-term sense, it did a bad thing.
So if you're facing that problem, if you've poured, you didn't give yourself enough time and it starts curing before you're ready, is there any salvageable thing, anything you can do to salvage it? Pouring water.
That, I don't have great context for that one. I haven't done enough like, that'd be a good question. My brother's a construction manager. He would have a much probably better, like, yeah, if you realize that, I mean, most of your concrete is poured and you're realizing you're hitting that cusp, I think often it ends up getting, often ends up getting jackhammered out and starting over. There may be some things that are better to do, but like I said, just adding more water is not a good one.
Not the thing.
Apparently that's what my home builder did on my driveway. Because I have all that chipping and the rocks I can see underneath. So apparently that's what they did.
It's a common thing that happens. And often I think that I think they know what they're doing and what's going to happen, but you won't see it in the time period that they're there, right? It'll look fine, but then down the road, it'll chip off.
Yeah.
Relatively low stakes when it's your driveway, but annoying, inexpensive nonetheless.
Right,
but if they parking garage, maybe a little more high stakes there.
Yeah, definitely. Okay. Well, gosh, everyone, thank you so much for being here. I hope you enjoyed the mock lectures that we had. Dr. Baker, thank you so much. And thank you for sticking around to answer some questions at the end. Our next session begins at 2, and it is the student research panel with Dr. Carter. So yeah, I guess we'll just let everyone go now and take a little break, walk around a little bit, and if you can come back at 2, that's great.